A very warm and cheerful welcome to all my viewers. Today I, Maaz Husain, student of Department of Civil Engineering, 4th year, Faculty of Engineering and Technology, University of Lucknow, is going to deliver a seminar presentation on the topic Use of Super Absorbent Polymer for Freeze Resistance and Internal Curing in Concrete. The flow of the presentation would be as follows. First, we will have some introduction and background study about concrete. Then we will have some background study about SAP, how internal curing is done using SAP, traditional method used for freeze-thaw damage in concrete, SAP for freeze-thaw concrete, freeze-thaw or freeze resistance in concrete. Then we will discuss some case study and experimentation done on the same topic till date. Then we will note down some key observation and finally we will end the presentation with some references. Introduction. Concrete is a very old, famous and reliable building material. Concrete is basically a non-homogeneous mixture of sand, cement, water, aggregate, and sometimes admixture are also added to it to alter the workability property of concrete. Although concrete is a very old material, but the problem of concrete, such as presence of unhydrated cement and the presence of void in huge number, remain unsolved till date. To solve all these problems, to some extent we are trying to incorporate the super absorbent polymer inside the concrete, which can act as an internal curing agent and freeze resistant agent inside the concrete. Thus in order to achieve this effect, it releases water to thus the effect creating an internal curing in the hydration process of cementation material. Admixture are used to provide early age freeze protection for concrete. Additive regulated concrete for thermally extreme condition are protect concrete from freezing above temperature of 23 degrees Fahrenheit, accomplished through freezing point depression and hydration. Here, I would like to add that admixture are not only added only to depress the workability or alter the workability, they are also added to depress the freezing point in concrete. Different type of admixture provide different benefit, but other than its main purpose, it doesn't provide only added advantage. Rather, it also comes with added disadvantages. For example, some of them which are increased shrinkage, less resistant to sulfate attacks. In some cases, accumulation of CaCl2 leading to corrosion of steel. Accumulation of admixture in a plane lead to distorted paints. Also, use of admixture means less fire resistant in concrete. Now coming to the background of SAP or superabsorbent polymer. Superabsorbent polymer is a type of polymer which is made by polymerization of arsenic acid blended with sodium hydroxide. Polymer which can absorb and retain many times their own mass in pure water. Their volume increases with absorption. The rate of absorption is highly influenced by the ionic concentration of water, commonly used in diaper, spill control, waterproofing, and artificial snow. How internal curing is done using SAP. As told earlier, concrete contain voids. Now these voids are also classified into two categories, macropores and micropores. Our main area of interest or study is macropores because these macropores size ranges from centimeter to micrometer. So now we are actually trying to incorporate the SAP into these macropores. Once the pre-absorb SAP is incorporated inside these macropores, and the concrete is casted, curing is done, and the shuttering work have been removed from the specimen, then the relative humidity inside the cement matrix gradually drops. Once the relative humidity drops, the SAP roll a picture or will come into picture. Uh, After the relative humidity decreases, the SAP will gradually release the stored water inside it. It will effectively elevate the autogenous shrinkage and promote hydration of cementation material. Therefore, the strength of concrete may be enhanced. Traditional method used for freeze-thaw damage or freeze resistance in concrete. Concrete can be damaged by the internal expansion of water as it freezes. Concrete contain voids. Now, these voids may also contain water. If they contain water and if the in surrounding environment temperature goes below the freezing point of water, then the water inside this water may become frozen. which lead to the buildup of internal pressure, which can be manifested on the surface of the concrete as expansive cracking. To prevent the damage by freezing water, air is entered into the concrete to prevent damage. In the air entrainment technique, uniformly disperse small spherical bubble act as void space or channel to relieve expansion of freezing water, thereby reducing total internal stresses. Typically, 6% by volume of concrete will be required for air entrainment technique. Now in, entrainment technique also have some shortcomings. Now, as we have told that air entrainment technique, air is rushed inside the concrete, also, or concrete or voids of the concrete. Now, when air is rushed, it may happen so that the size of void may also increase. Once this void size is increased, it will lead to reduction of compressive strength. Air quality is difficult to control, particularly when other admixture are also present. SAP for freeze thaw in concrete. Now, when we are trying to incorporating external material inside the concrete, such as SAP, we must also know the effect of concrete on the SAP. As we know, concrete is highly alkaline, average pH 13. So it may lead to lower SAP absorption. The absorption rate will be minimized from 100 times to 5 to 30 times. SAP deabsorb as concrete hydrates. Void space left as SAP shrink. More complete hydration, lower shrinkage, denser microstructure. Void space, like air entrainment, provide space for ice to form as concrete freezes, preventing damage due to the expansion. SAP must be smaller than 100 microns to be correct size when swollen. Now we are going to discuss about the case study and experimentation done by the College of Civil Engineering, Zhengzhou University, China. They basically used a M25 grade of concrete which contain ordinary Portland cement and coarse grade aggregate made up of crushed granite of size ranging from 5 to 20 mm. The fine aggregate was National River sand with a fineness modulus of 2.37. SAP use was varied from zero point 0.5 to 1.35 kg per meter cube of concrete. Now, preparing the specimen according to the given specification, the concrete was poured inside the pores of 15 by 15 meter cube centimeter cubes, and they were subjected to the ordinary test of workability, compressive strength, and shrinkage. When after when the concrete with containing SAP was conducted was subjected to slump test, it was found that slump increases when the pre-absorbed SAP was added, and the slump increased with the increase of SAP volume. It indicates that pre-absorbed SAP present as spherical fine particle, and this can play a lubrication role in concrete mixture to reduce the friction between slurry and aggregate. It can also increase the fluidity of the mixture as well as increase the slump of the mixture. The more the amount of SAP is added, the more the obvious effect is. Compressive strength. At 28 days, the compressive strength of SAP concrete is basically the same as that of the normal reference concrete, which shows that SAP has gradually played the role of internal curing. Shrinkage. As we have noted earlier also, that during the initial stages, the concrete which contained SAP was going a lot of variation in the water content. So initially the shrinkage was more, but at later stage or after 28 days, when relative humidity inside the concrete decreased, SAP releases the internal water stored to supply the water consumption in concrete. It can also reduce the evaporation rate of external water as well as elevate the relative humidity gradient of concrete so as to improve the drying shrinkage of concrete. Now, the result of all the tests which were conducted previously are shown graphically here. Here x-axis stand for the specimen. For example, the PCB means plain concrete specimen with named as B. PCZ mean plain concrete with name as Z. S0, S10 and S10K stand for specimen containing SAP with varied percentage of SAP. Here we can see as days passed on and the specimen with more and more SAP containing more SAP was showed a positive result. Now here we are going to study another SAP study. This time our goal will be to provide an alternative method to air entrainment for making concrete resistant to freeze thaw or freeze damage. Objective evaluate SAP as potential additive for fire resistant in concrete containing freeze protection admixture. Evaluate potential for strength gain due to admixture due to additional moisture provided during curing by SAP. The second study of SAP was done by American Concrete Institute. Uh, the range of SAP addition was targeted at 6% swell in SAP by volume. Exact absorption rate in concrete was uncertain. Uh, Although amount added was ranges from 5 ml to 45 ml per gram. Four doses assuming absorption rate of 7.5, 15, and 30 and 45 ml per gram. All concrete made with and without freeze protection additive, mixed and cured at 23 degree Fahrenheit for 28 days, 7 sacks of OPC or 0.42 water to cement ratio, 5 ml nominal size aggregate, control with SAP air entrainment and no air entrainment. So basically, the specimen was prepared according to these given specification, and they were subjected to various tests. When these they were subjected to test, they were subjected with air entrainment and no air entrainment of the specimen containing SAP. Case study to SAP testing. Tested medical mechanical properties and freeze thaw durability at 728 90 days, unconfined compressive strength, 28 90 days, modulus of elasticity, resistant to damage from freezing and thawing. Now the as w- the specimen containing SAP was subjected to various tests, of which the one is the compressive strength test, and the results are shown here as follows. Towards the left, we can see the first specimen, which was on which the test was conducted in control environment with only air entrainment of about 2.2% of whole volume of specimen. Now, this specimen shows the most valuable result, and it can be used as a reference concrete. So, using it as a reference specimen, now we will compare all the other specimens. Here we can see as air was increased in the second specimen, the it shows basically no change or variation in the 90 days strength. Now air entrainment was decreased, and percentage of SAP was gradually increased from 2.25 to 3.5, 7, and 40. Although at a random value of 3.5 lb per yard and 2.4% of air, it was found that it shows a great variation or positive result in the 90 days strength. So more air intake, more use of SAP doesn't necessarily mean more positive result. Uh, 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 the best result can be received at uh, a random combination of SAP and air intake percentage of air entrainment. Here we can also see that variation at 7 days, 7 days was more. Also, so we tried to ignore this 7 days strength, and now we are trying to going to show the 28 days and 90 days strength on another graph. Here also we can see at a particular random value of SAP and less air entrainment, it shows a positive result comparable to that of the control environment containing air entrainment technique. Now, the specimen was subjected to another test for determining the relative dynamic modulus. In this test, the specimen is subjected to a cycle of freezing and drying, which is known as one cycle. So, accordingly, the specimen was subjected to all this cycle, and from the various formulas, the relative dynamic modulus of concrete was tried to be founded. Now, when the if the relative dynamic modulus value of original concrete or decreased to 60% of that of the original, the specimen was assumed to be failed. Here we can see even in the control environment, the specimen failed as the number of cycle increased. But here we can see with less use of SAP, uh, without air entrainment, we were able to achieve a relative dynamic modulus value more than even of that of the original at about 110%, comparable to that of a controlled air entrainment technique, which is very costly. So now we are going to note down some key observation. SAP is capable of providing concrete with resistance to freezing and thawing without entrained air. in concrete containing freeze protection additive and cured at 23 degrees Fahrenheit. Possible to have too little SAP if sample failed. Higher amount of SAP improve 7-day and 90-day compressive strength. Improve properties with economical amount of SAP. Now we will reflect some references here. Now I would like to end the presentation by saying thank you to all my audience, and please do hit the like button and subscribe to our department channel to get more interesting videos on the civil engineering topic. Thank you.